The world needs to know how to do handheld laser welding. The quality of weld that you can get out of it was just absolutely amazing. Once you have that curiosity and that passion to see what it can do, it unleashes a whole new world.
So I was wrong about handheld laser welding. I did the one thing that I tell everybody not to do. I kind of kept it at arm's length for a few years. I saw laser welding at Tack, and I thought that, it's kind of a cute little toy. I ended up taking a class, and Rex was the instructor, and he showed me how he's welding spaceships together with it. New welding technology can be scary for people, especially if you don't fully understand it. And I needed to take a deeper dive into this with Rex, and it really opened my eyes to the capability of this process. We're here in the Handheld Laser Institute in the lab to do some handheld laser welding. And we want to talk a little bit about your background, how you got started.
So I'm an Ohio State welding engineer. Always thought welding was cool, never wanted to sit at a desk all day. And so I went to Ohio State. I got my bachelor's and my master's degree in welding engineering. Did a lot of my master's research in TIG cladding for subsea pipelines.
Okay.
And along the way, interned at SpaceX. I always thought the aerospace industry was super cool. And coming out of school, I actually took a job with Blue Origin instead of SpaceX because they needed someone who knew about cladding.
Okay.
To build their BE4 engines. And so that was really my first introduction to lasers and the world of lasers, was just based on my cladding experience. When COVID came around and everything hit the fan, SpaceX had been trying to hire me for a while. So I started at SpaceX as a welding engineer down in Boca Chica and was hired to build their laser welding program for Starship.
That's rad.
Yeah, it was super fun. I mean, going down there and like working in a circus tent on the beach, it's kind of an environment that lasers should never be in.
And this is early SpaceX days.
This is early Starship days. Yes, this was like the beginning of 2020.
Okay.
When I went down there. And so I showed up and there was a half-built machine with a laser. And of course, it's in a tent on the beach, humid, hot, sandy, the worst conditions for a laser.
Yeah.
And did that with automated lasers for about a year or so, doing welding and cutting. And then one night, Elon had seen a handheld laser on Twitter. Mm-hmm. This is pre-X.
Yep.
And he went on Amazon and just bought this Chinese handheld laser. And it showed up in South Texas. And I didn't want anything to do with it. Mm-hmm. It seemed like a horrible idea. It ran on 380, and so I just never bought a transformer and just kind of like swept it under the rug for a while. And then IPG came out with their light weld about a year later, and IPG making a handheld laser, like to me, was kind of a signal that maybe there was something else going on here and I should pay more attention to what's going on. IPG is the world's largest manufacturer of fiber lasers. So we opened up the crate and looked at it, and still this seemed like such a bad idea. So we crated it back up and put it in the corner for a few months. And I was doing these really long, narrow laser welds on the barrels of the Starship. And all of our TIG tacks were too big, and they weren't visually consumed on the edges of that weld. Mm-hmm. So we're getting a lot of rejections by the inspectors.
Okay.
And I was like, dude, maybe this handheld laser could tack all this together. So, I mean, we already had a laser enclosure, so it's like a really easy place to go try it. So we started doing it, and it worked great. The tacks are so much smaller. And one day, one of my TIG welders walked over, and he was like, hey, do you think we could like play with that and see what else it can do? And I was like, yeah, sounds like a great idea. Like I hadn't done anything else with it yet because I didn't know what to do with it. And so we just brought over some scrap material, like 3/16 stainless, and started playing with it. And he was welding right through full penetration this groove weld. Mm-hmm. And it blew blew both of our minds. We're like, wow, this is actually really cool. But with the way that the torch is set up, this was pre-wire feed, so it was all autogenous. Okay. And so you had to drag the torch along the part, and any change in surface roughness or shape made it really difficult to control your travel speed. And that's one of your most critical process variables with a laser weld.
Yeah. And so, with regular welding too, actually.
Yeah, right?
You want to make sure the weld is consistent all the way across.
Yeah. So maybe with a lot of practice, we could have gotten to the point where we could do it autonomously, but it wasn't something that I was comfortable putting out into our production.
Leave it to welders to be creative though. Like, take this out of the box. What else can we do this?
Welders are some of the most creative people I know.
And also, for some reason, the people that want to keep this at arm's length, somehow they're like, that ain't going to work. And it's like, why don't you just mess around with it a little bit and see?
It's all about, I think, succeeding with handheld laser is all about like having that curiosity and having that passion and just wondering what it can do. So many people see it as something different or misunderstood or dangerous, and nobody wants anything to do with it. But once you have that curiosity and that passion to see what it can do, it unleashes a whole new world.
So after you've taken the machine out, you did a little bit of testing, a little bit apprehensive. Like, where did you start to see some traction with the handheld laser?
So I didn't actually gain any traction with it. Obviously, I'm not going to convince anyone that it's a good idea until I believe that it's a good idea. And so it still sat. We tacked for a few months. And I went to FabTech back in 2021. And this is when IPG released their first wire feeder. I saw it and I saw people using it, and the gear started to click because the wire pushes the torch along the joint. And so for me, this was the last missing piece of that puzzle, that now your travel speed is controlled and the process can work the same way that automated laser welding has worked for decades. And the first time I used this with a wire feeder, I was giggling like my 4-year-old when I let him drive the lawnmower. Like I was like a little kid again, because it was such a different experience. And the quality of weld that you can get out of it once all of your variables are controlled is just absolutely amazing. So at this point, like all the gears have started to turn in my head, and I was like, okay, well now I need to find someone who will let me use this in production. And every time we had a new application request in our welding lab, I would try to figure out how to do it with a handheld laser.
Okay.
And so like playing with different filler materials and playing with different size filler materials and playing with the parameters and trying to tweak them for different joints. And this was like the perfect storm because I had my laser lab, and then I had mechanical testing equipment and my metallurgical lab like just around the corner.
Right.
And so I could do stuff in the lab, turn around and go see how it stacked up immediately against arc welds. And after like a month or two of playing with it, I was convinced that it could compete. And I started like literally begging engineers to let me use it. And some people started giving me things where maybe I could use it and then it would get shot down. And everybody was too apprehensive to use it in production. And finally, we had this one part. It was thin mesh welded to a fairly thin sheet, but we had one guy who could TIG weld it.
Yeah.
We needed to make dozens of these parts.
Yeah.
And so this poor guy was stuck with me. There was no other way to do it other than handheld laser. And so we qualified our first procedure, we built our first production cell, we trained up a couple guys, and then we just let them have at it.
It wasn't the welder, like you kept the awesome welder that you guys had, that really badass TIG welder, you kept him doing the super precision TIG welding work. You didn't take him off and put him on the laser.
Yeah, what's funny actually is we trained a couple of guys who were experienced TIG welders, and then there was just another guy who was really curious about what was going on, and so we just pulled him in as well and trained him, and he ended up being one of the best welders at SpaceX.
Yeah.
This is where I say, like, it's not necessarily your historical performance. Your historical performance, arc welding, will help you understand how to fabricate and prep things for laser welding, and I think give you a leg up. But it's all about that curiosity and sparking that interest that will make you succeed here. I, in my mind, could see what this was capable of. And in the interim, we had built all these huge robotic laser welding systems, and we were minimizing distortion elsewhere on the vehicle. And then these guys would come in with their MIG torches and just decimate my work of art.
Mm-hmm.
And it would go from this like perfect looking nose cone to just being like this wrinkly potato looking thing.
Yeah, yeah.
And I knew if we could just handheld laser weld that it would remain that same shape that we had when we built the original assembly and laser welded it with the robots. And so I begged these engineers for months to let me laser weld this, and nobody wanted to let me do it. And finally, Elon was walking around one night and he was like, hey, that looks like garbage. You guys got to fix that. And so I came into work the next day and I had this posse of engineers waiting for me. They said, please, let's do this right now. And I was like, dude, this is what I've been waiting for.
Yeah.
But a lot of the apprehension, at least from a structural standpoint, comes from the design engineers, right? And it's very much a circular conversation. I find this both when I was at SpaceX and working with a whole bunch of other customers now with the Handheld Laser Institute, is especially with this thinner sheet metal, your design engineers are designing to the limitations of arc welding. So they might call out a 3/16 inch fillet, but that's just because that's the lower end of what you can do with a MIG torch.
Right.
And you go ask them, well, how strong does it need to be? And they say, I don't know.
Right.
How strong is your weld?
Yeah.
So part of the equation is like figuring out how to close that loop and give your designers the information they need to know how to use the technology.
People that have been designing things a certain way with arc welding in mind for decades. It's basically all we know.
Yep.
So, of course you're going to get pushback from people like, well, I don't know, like, why would you put a tiny little weld in there? It's like, do you need the big weld? And they're like, we think so.
Yeah, and like that's sometimes a very difficult conversation to finish. But if you can show people the data, it becomes a different story. So I generated a bunch of data for these guys, and I was like, hey, look, we can actually make a handheld laser weld that has like a 50 thou leg on your fillet, and it'll compete with 150 thou leg TIG fillet. And that blew my mind.
With a lot less heat input.
With a lot less heat input. It blew a lot of people's minds. And so then we put it into production and started doing it. And all of a sudden, not only had we reduced distortion by a factor of 10 on this part, but also we had increased our production rate by like 5 or 6x. Unintentionally.
Right.
We never meant to build things faster.
Right.
But the structural performance, the speed, and the reduction in distortion caught everybody's eye. And so all of a sudden I had all these design engineers saying, hey, can you help me figure out how to weld this or that or this piece? And so I spent a lot of time in my lab developing and qualifying custom procedures for all these different applications. And it took up a lot of my time. Eventually I got to the point where I kind of like consolidated all of my weld data and just made a whole bunch of pre-qualified procedures for different materials, different joint types, different loading configurations, and just said, hey, designers, here's this chart. You want to make this type of weld in this material. Here's what you can do based on the strength that you need. And within a month, I lost track of what we were handheld laser welding on the vehicle. It just exploded. It became a normal process at SpaceX. And then I would go home and look at the internet and see everybody on the internet saying, oh, that's fake. There's no way that's real. That's dangerous. You're going to shoot your eye out. That weld's so cold. There's no penetration. And like, it would just make me boil inside.
Yeah, because you're like, I know that there's the data.
Exactly. And I think there's a really great parallel here, actually. I was training some people in Canada last summer, and these guys had just gotten their laser, and they were fabricating all these parts, and this old guy walked in. He was like 65, 70, and he was so excited to see the laser. He had just sold his fab shop. And he walked in and I was talking to him and he's like, this is so cool. I love this technology. It reminds me back in the 70s when MIG welding first came around and nobody believed in it.
Yeah.
And I was born in the 90s. I never experienced that.
Yeah.
Right? And so
I hear stories about this.
For me to hear this old guy make this corollary, I was like, dude, you're so right.
Yeah.
It's a new process that nobody understands, but if we can build that level of understanding, it will become normal. And so that's why I quit SpaceX. I gave up a lot of stock. I gave up a very high-paying job. My wife asked me all the time as I was getting ready to quit. She was like, are you sure you want to do this? Like, you're giving up a lot to do this. But the world needs to know how to do handheld laser welding, and I want to help people understand how to do that. And so I founded the Handheld Laser Institute.
That brings us basically to today. Now you have the Handheld Laser Institute. You're doing private consulting for companies that are looking to do handheld laser welding. So that's procedure development, the inspection side of it. Like, you can handle a lot of the testing, some of that stuff in-house. And then you have obviously other inspection agencies that you work with, right?
Yeah, exactly. So I work with everyone from like mom and pop job shops all the way up to like major aerospace corporations. And it's anything from, like you said, procedure development, qualification, weld characterization, training and education. So I actually fly all over North America and show people how to use their equipment, all the way up to like building complete laser welding programs for companies to say, hey, here's the safety side. Here's how you train your guys. Here's how your engineers understand how to develop all your procedures. Here's how you develop repair procedures in the field. And that's all the kind of information that I also want to do on my own and then be able to provide the welding industry as a whole.
Where do you start, I guess, with laser welding safety? What's the biggest concern, I guess?
So the important thing to know about a laser is that we're dealing with infrared light. So the wavelength of light is actually what makes the laser unique and what makes it be able to penetrate so deep into your parts. That's also what makes it somewhat dangerous for your eyes. So this is not like arc welding where you'll get arc flash, and if you don't treat it, maybe eventually you'll go blind, right? With the laser wavelength, even if you catch a reflected beam, your cornea will refocus that beam onto your retina and vaporize part of your retina.
Yeah, the vaporization part is usually where people get kind of scared.
It's not good.
Yeah.
So best case scenario, you catch a reflected beam in your eye, you get what we call a floater, a little black spot in your vision, kind of like if you had a cataract. Worst case scenario, that's the last thing you saw.
Yeah, that sounds horrible.
It's not what I want to deal with, right?
But you've been welding a long time and no injuries from laser welding.
Yeah, I've been laser welding for the past 8 or 9 years. I've been doing handheld laser welding specifically for the past 4 years. I've trained hundreds of people how to do handheld laser welding, and I've never encountered anyone that's actually had an ocular injury, damage to their eye from handheld laser welding. Usually what I see is guys who are used to TIG tacking will put their fingers right next to the torch and they'll shoot it and they'll shoot through their glove. Now that I've seen a few times.
Yeah.
The important thing is just understanding you need to have the proper safety gear to protect your eyes from the laser. So we've got here some laser safety glasses. We've got a few different kinds of laser safety glasses. The laser safety glasses, what we need to worry about is how much of the laser wavelength are we blocking. So this laser that we're using today is a fiber laser. So it's 1070 nanometer wavelength. And ANSI Z136.1 governs the use of class 4 lasers in industrial situations. And this, whether it's medical or whether it's welding or cutting, it governs all the use of these high power lasers. And so what it says, there's a bunch of math and calculations and testing. They actually did all this testing back in the day on monkeys.
Oh God.
Okay. So they actually shot the monkeys. So
horrible.
They shot the monkeys in the eye to see what different laser powers would do and to characterize what sort of laser protection you need to keep your eyes safe.
Hopefully that was a short test.
Yeah. When we're doing laser welding, we want to have our laser safety glasses on at all times, but then we also want to wear some sort of welding hood. This is the hood that I started laser welding with back at SpaceX. This is just a standard Sentinel. There's nothing fancy about it. And back in the day, nobody made laser welding helmets. So I was always a little nervous when using this with laser welding. And so I would always kind of like squint my eyes and like so I could feel my laser glasses on my cheeks before I would weld. But it worked. It's safe. You can do it. You just put it on grind mode. The UV coming off of your laser weld is nowhere near as bright as when you're arc welding. So you can get away with like a shade 3 to 5 instead of a shade 9 to 13 when you're arc welding. A few years ago, IPG came out with this carbon fiber helmet and I actually had one of their first 3 prototypes. And I used it exclusively for years. I loved it because this gives you another layer of laser safety. So there's actually a reflective filter and a transmissive filter in this helmet. Wearing the glasses and the helmet, I no longer worried about welding. I knew my eyes were safe all the time. But you really do want to have those 2 levels of laser safety on your eyes when you're welding. So I think part of the battle with handheld laser welding is understanding where to use it and not just how to use it. So one of the things I think that's valuable to talk about is how do we pick good joint geometries for laser welding and how do we find the right applications for it? The thing to keep in mind here is our wires controlling our travel speed and pushing us along the joint. So it's all about how do I find a joint that the wire can reference against and move easily along that joint. So I think like a T-joint is a really easy one. The wire just sits right in that corner and you just travel right against it. A lap weld is pretty much the same deal. You've got that reference surface. Now, if your top sheet is really thin, it might be a little more difficult, but the same principle applies. A corner joint, I think, is also typically pretty easy. It all comes down with a corner joint to controlling your gap size and being able to close that without blowing through it. If your gap size is too big, the laser is going to shoot straight through that gap.
Could be a problem for whoever's on the other side.
It could be, but we can close gaps. I think one of the unique things about handheld laser welding, because we're using that wire, it's not as sensitive to traditional laser welding as far as fit up is concerned.
Like autogenous welding, things literally
they have to be touching, right?
Yeah.
So with traditional laser welding, you have to have a fit up that's tighter than 5/1000 of an inch.
Yeah.
With the handheld, because we're using the wire, I typically tell people you can close anything up to about 1/2 to 2/3 of your wire diameter.
Okay, that's fair.
It's a lot more generous.
Yeah.
Butt welds are one of the last. I think butt welds are one of the trickiest things to do with handheld laser.
Yeah, because it's just hard to get that.
Well, it's hard to track that joint.
Yeah.
So like if you put this joint down and we take the torch and we try to track that, you're just going to be skating, especially when you're moving up to 10 times faster than TIG or MIG welding. Yeah. You're going to have such a hard time tracking that joint. There's no reference surface. So what I usually do is just take an angle grinder or even like a file and just break that edge, put a really small chamfer on that edge, like a 20,000th chamfer, and then you can butt that back up together and the wire will just sit right in that little chamfer and ride right down the seam. Now, where I see most people using this is all in like thinner sheet metal.
Yeah.
Like say 10 gauge. Some people I know are using 8 gauge, but it's really like excels at 10 gauge and thinner.
Yeah.
As long as you have the right fit up and you have those joints that we were talking about.
And a lot of that stuff, is not structural, like, restaurant equipment, kitchen stuff. I mean, all those things that are very, very, very difficult to find a skilled TIG welder to weld out. I mean, you could get somebody that doesn't necessarily have those skills to weld them out with handheld laser.
Exactly.
Get better results, less heat input, and extremely repeatable because you're just letting the machine push you along the joints. The welds look exactly the same all the time, no matter who's welding.
It looks like a robot.
It does. It really does.
It really does.
It really does.
And, that's, I think, where probably 90% or more of the industry is right now, at least in terms of people who have started adopting handheld laser welding, is it's all of that aesthetic, thin sheet metal stuff where strength and performance and code requirements don't really come into play. But I think we're beginning to see a growing number of people who are interested in making handheld laser welds to existing codes and meeting those requirements. And while it's not explicitly called out in any existing codes, you can still very easily make code-worthy welds with handheld lasers. Yeah, so we'll make one little sample here. The first thing we're going to do is tack it up. So I'm going to go back to the laser. I've got a few parameters pre-programmed in here that I developed previously. So we're going to start with a tack weld, and we'll tack up a T-joint here. And once it's tacked up, we'll start laying down some fillets.
Awesome.
So one of the tricks when tack welding is getting your torch angle set just right. So when we're using this torch, it's designed so that the handle here should be parallel to the joint that we're welding.
Okay.
And that will allow us to align everything properly, get the right shape fillet weld, but then also keep the reflected energy pointed away from us as we're welding. So one of the things that you'll see here when we stack up this T-joint is the little pilot laser in there kind of bounces around depending on where I have my torch angle.
Oh, yeah.
And what I want to do, once the handle is parallel to the joint, you'll see all of those dots converge in a single spot.
Yep.
That's how I know it's aligned. I can pull the trigger and I can make the world's tiniest tack weld. Now they are really small. Usually what I do is I'll put a few tack welds on one piece before I start welding it so it doesn't come apart. So we'll put 2 on that side, we'll flip it around, 2 on the other side. And now we're ready to make some fillet welds.
Is that tack weld program, you just stay on the trigger the whole time? Is it
yeah,
like a
so we just pull
cycle?
the trigger. So on the front of the machine here, we've got the power, and we've got here where it says wobble frequency. In this instance, this is actually telling us how many seconds long our tack weld is.
Gotcha. So it just stays on for 0.6 seconds and then shuts off.
So now that we're in the welding mode, the wire is enabled. So if I just pull that trigger, it's going to pay some wire out. And for starters, we want the wire to be right where that little red dot is.
Okay.
And that's going to make it so we don't burn through the part when we start, but then also if we had excess wire, it would leave kind of a little wire stub at the beginning of the weld.
And you don't have to worry about shooting yourself in the hand when you're paying the wire out?
No, so when we're holding and I'm touching it like this, nothing's going to happen. There's a few things the torch is looking for before it can weld. One of the things, there's actually 2 triggers on this particular model. So this is a dead man switch right here. And you'll see once I pull the dead man switch, we have gas coming on. That pilot laser turns into a line and this green light turns on. The other thing it's looking for is this safety circuit that's clamped to the table. So I can't fire this off into the distance. If I touch the part, now that safety circuit is closed, the torch is flashing, we're ready to weld. So if I have it up here, I couldn't fire the torch if I wanted to. So again, I'm gonna hold the handle of the torch parallel to the joint that we're welding. And I am just gonna let the wire push me along this joint. We'll weld about an inch or 2 and then we'll terminate. So we're splitting that at an even 45, and we'll pick the torch up and make a clean termination.
Yeah, that's the part that I'm gonna struggle with for sure.
Yeah.
That little flare at the end. I'm gonna try and not mess this up.
Let's see how you do.
All right.
I believe in you.
Yeah, this is like my 5th laser weld ever. So let's see if we can, and I already can tell like I want my other hand on this.
I know.
I know, I want it so bad.
So just for practice, put one hand on the table.
Okay, one hand on the table.
Yep.
Then I'm gonna try and start this right in the joint. So second trigger, first trigger.
Yeah, and just let it push you along.
I see what you mean about wanting to have it like in the joint.
There you go. That looks pretty good.
Not terrible.
You got a really nice tie-in to my weld too.
Hey, that's teamwork right there.
We're gonna do a bit of an experiment here. So we've got 1/16 inch wire. This is 308L. We're welding 304L. This is 3/16 inch thick. So what we'll do is we're gonna use our parameters we've been running for your practice welds at 800 watts. We'll make another fillet weld at 1500 watts, and then a few other welds with larger diameter wires, and we'll go break them on the tensile tester and see how they compare.
I'm always down to break some welds open.
That's what makes it fun.
This is the data.
So the first weld we made was with 062 at 800 watts. So this is kind of my favorite diameter wire to use on a spool. Lets you close those bigger gaps and make bigger fillets. So this was about a 60 thousandths leg fillet. And again, we look at the back side and we've got clear evidence that we've penetrated fully at the root. Now this weld we developed in the lab specifically to be able to penetrate to the root and not any further.
This is where things get
This is where it gets interesting. This is where the power of laser comes into play. Then we took that same 062 wire and we cranked up the power to 1500 watts. So we're looking at getting much deeper penetration into the material.
Wow. 17.
We might max out the machine. But this is where the magic of laser comes into play.
17,000 pounds is a lot.
It's a lot for a
an
little
inch and a half weld.
For an inch and a half weld with a 60 thousandths leg.
Yeah.
It's crazy. Then we used the TIG rod feeder and we fed 330 seconds 308L. I really don't want to break the jaws though. Oh, she's coming down. And we pulled a little bit stronger. We're right on the edge of maxing out this machine here. What's interesting here is that even though we only had about an 1/8 inch leg on this weld, we still failed in the 3/16 inch thick parent material.
Yeah, that's pretty impressive. This one was pretty fun to watch.
It was exciting.
Yeah.